right, hello everybody. Today we're going to talk about factoring trinomials completely. So before we get into factoring completely with a trinomial, I'm going to talk about factoring completely with just a number. So let's use the number, let me scroll that down there. Let's use the number 24. So if I say, okay, factor 24, you might say, okay, well, you could have 1 times 24 or 2 times 12, 3 times 8 or 4 times 6. And then you could reverse all those and have 6 times 4 or 8 times 3 or 12 times 2 or 24 times 1. And all of those answers are, in fact, factors of 24. But if I said factor it completely, you'd have to keep breaking it down into smaller pieces until all that you had left were prime numbers. Think prime factorization if you've ever done that before. So I'm going to start with 24 and I'm going to say, well, that's 4 times 6. And I say, well, I can break 4 down into 2 times 2. And I can break 6 down into 2 times 3. And then what I'm left with is nothing more than the prime factorization, or the prime factors, which would be 2 cubed times 3. So I factored 24 completely. We're going to use that same logic as we look at factoring a trinomial. So I'm going to scroll down here to my trinomial. Now, when I gave this problem to some students, they looked at the problem and they said, oh yeah, we can factor it. And the first group said, my answer is 3x plus 9, excuse me, not plus 9, it should have been 3x minus 9, times x minus 2. And I said, oh, great work. And the other group said, no, they got it wrong. Our answer was x minus 3 times 3x minus 6. And I said, well, you're both right, but neither answer is factored completely. So what we talked about from that point was, how do we break this trinomial down into where it's prime factors, or we have a complete factorization. We've pulled everything out that we can. We've broken it down into the smallest pieces. So if I look at my problem here, I'm going to look and see what I can take out of each value. So I've got 3x squared in the front, and then minus 15x, and then plus 18. Since I don't have an x in each value, I can't factor out an x, but I can factor out a 3 from all three numbers here. So let me switch my color back here. So I'm going to take that 3 out, and I'm going to see what's left. I'm going to divide each piece by 3. So I have an x squared, a minus 5x, and a plus 6. So this is the trinomial that I'm going to factor now. So I'm going to go back to what I've been doing, and I'm going to start with the diamond problem. And I'm going to say, okay, I have 6x squared at the top. At the bottom, I have a negative 5x. So two numbers that I can multiply together to get 6x squared but add up to a negative 5x would be a negative 3x and a negative 2x. So I'm going to go over here and I'm going to draw my generic rectangle. Now, when I draw my generic rectangle, I know in the top left corner, I put my x squared value, and since I've already factored out the 3, I don't have to put that 3 in there. In the bottom right corner goes my constant, my c value, and then I'm going to put the other two values in the other two spots. And then I'm going to factor out each row and each column so that I can see what goes around there. So let's see here. I can take an x out of both of these. I can take a 3 here. I can take an x out of both of these, and I can take a 2 here. Now, I notice here that these two are both negative, but my c value is positive. And the only way that you can get negatives for your two side values and then a positive is if these are minuses. So I'm going to end up with x minus 3 times x minus 2. Now, at this point, because I'm doing the complete factoring, I have to bring that 3 back down and list it here. So my complete factoring of that trinomial would be 3 and then times x minus 3 times x minus 2. Now, if we go back up to the problems that my students did, we'll notice that each one of these is missing where that 3 was factored out. In this top problem, I could factor a 3 out of both of those. If I did that, that would be 3 times x minus 3, which would match my problem. If I look at the second one here, I can factor a 3 here, which would make 3 times x minus 2, which again makes those answers the same. They just weren't factored completely. I hope this has been helpful. Have a great day.